Okay, in this video, we're going to talk about a concept in Unit 6 called impulse. We're just continuing on talking about momentum. But first, we want to review over momentum. Now, momentum, we can define this by an equation where momentum is equal to mass times velocity. So the P stands for momentum, M for mass, V for velocity. Now, our units we know for mass are kilograms. Our units for velocity are meters per second. So our units for momentum, which is P, is kilograms times meters per second. Now, another way of writing that, kilograms per second, we can also call that Newton seconds. So basically, 1 kilogram times meter per second is equal to 1 Newton second. They're the same unit. Another thing we talked about was the change in momentum. We have to change our equation slightly. We have that triangle, which stands for change in. The change in momentum, which is P, is equal to mass times the change in velocity. We can write the change in velocity differently. We can extend that out and write, change in momentum is equal to mass times Vf minus Vi. Now, keep in mind if something is moving to the left, we take that to be negative. If something's moving down, we take the velocity to be negative. And if something, rebounds from something, say there's a wall, and then you have your initial velocity, in this case would be positive, and if it bounces back, your final velocity would be negative. Just keep that in mind while you're working these problems. However, if the velocity of something just speeds up, then both velocities would be positive, the initial and final. And if it says something begins at rest, that means the initial velocity is 0. And it says something is stopped, comes to a stop, that means the final velocity is 0. Now we're going to look at impulse and what exactly is the definition of this. Well, impulse is a force applied over a time interval and resulting in a change of momentum. So pretty much a way of defining impulse is a force applied over time, or impulse is also equal to change in momentum. And we have some equations, the way that we relate this to math and the way we can solve for these different variables. Our equation, and we have a few of those for impulse. Impulse is equal to force times time. So we know that force, the units for force are newtons. Time is in seconds, so we're going to need our time in seconds. Our force is in newtons, so the units would be Newton seconds. We could also use kilograms times meters per second, the same as momentum for impulse. And the equation we're going to use is I equals F, and then multiply that by time. I equals Ft, that just means force times time. I could write it out like that. Now another equation that we have is impulse is equal to change in momentum. So we know that the change in momentum is delta P. So I impulse is equal to the change in momentum. And I know that the momentum, change in momentum is M times delta V. Right? So I can plug that in, M times delta V, and say the impulse is equal to M times the change in velocity. And I can extend that equation on out and say the impulse is equal to M VF minus VI, since the change in means final minus initial. So all three of those equations say the same thing. I equals delta P, I'll just plug in M times delta V for P, and I equals M times delta V. And then break down the delta V to VF minus VI. So all three of those are ways of showing impulse. It will just depend on what the problem tells us about which one of those equations that we will be using. So if I look at a problem here, a ball is stopped by 100 Newton force over a time period of 2 seconds. Determine the impulse acting on there. We're using the guess method. First, I'll write down my givens. My givens in the problem gives me 100 newtons. Newtons tell me force. So force is equal to 100 newtons over a time period of 2 seconds. Now my units are right in seconds. If they would have been minutes, I would have wanted to convert it to seconds, or hours, I'd been wanting to convert it to seconds. It's asked me to determine the impulse, which is I. My equation, the equation I'm going to use for this one is I equals F times T. I have to pick the one that, my givens will tell me which equation to use. And then I is equal to force, be 100 times time interval 2. And that would give me 200. And the units would be Newton seconds. Although I could use kilograms times meters per second. Those units are the same. Normally I'd round to 2 decimal places, but since it gave me a whole number, it's alright just to say, 200. Now, according to Newton's second law, an unbalanced force acting on an object causes it to accelerate. This acceleration produces a change in the object's velocity and consequently its momentum. This is called the impulse momentum theorem, and I have an equation for that. My equation that I'm going to use is this one, F times T. So it's telling me impulse is equal to the change in momentum. The change in momentum is going to be M times delta V, which I know I can rewrite that as F times time is equal to M VF minus VI. Most of the time I'll be using this second equation because I'll be given a final velocity and initial velocity. However, if it ever asks me to solve for the change in velocity, I would want to use this top equation here because I'd be solving for, delta V. Now, so basically what this equation, impulse, tells me impulse is equal to F times time, which is equal to the change in momentum, which is equal to M times delta V. So I could plug it around. I is equal to F times T, I is equal to delta P, I is equal to M times delta V. And it just depends on what the problem gives me about which one of these equations that I'm going to use. So real world connections between impulse momentum and airbag stops a person by spreading the force over a greater time, therefore decreasing the magnitude of the force acting on the person, since the change in momentum would be the same whether it's an airbag or not. What's the mathematical explanation? Well, if I look at my equation for the impulse momentum theorem, now an airbag, what does it do? Well, when you hit an airbag, the time interval is increased. Because if you hit like a hard steering wheel, the time interval is going to be really short, but it increases this time interval. So when it increases that right there, it's going to decrease the force at which you hit the airbag with, as opposed to hitting the steering wheel. Now next, a baseball bat is instructed to fall through with a swing. This keeps the bat applying a force on the ball for a longer period of time, therefore producing a larger impulse and a larger change in the ball's velocity. So if I looked at it from this equation, from this point of view, and it says follow through, you keep for a longer period of time. If you increase the time interval that the bat stays on the ball as you follow through, it's going to make the velocity, change in velocity, increase also according to this equation. And if you increase all that, the force at which you hit it with is going to be higher also. Now if we look at some example problems, our first problem says a force of 20 newtons acts on a 3.50 kilogram object mass per 10.0 seconds. What is the impulse of the object? If I want to write down what the problem gives me, it says a force of 20.0 newtons. It's giving me a force on a 3.50 kilogram mass, and the time is 10.0 seconds. What's the impulse? Well, what equation of impulse am I going to use? Based on the information it gives me, the only equation I could use for impulse would be force times time. It gives me a mass, but it doesn't give me velocity, so I can't use, impulse equals mvf minus vi. It doesn't give me a velocity. So my mass in this case, really, I'm not using in this problem. So my impulse, when I plug that in, my force is 20.0 times 10.0. When you multiply that out, that would give you 200 and 0.0 Newton seconds. Or I could have said kilograms times meters second, which would have been fine. Next, in the B part says, what's the change in speed of the object? Alright, so when for my change in speed, it is, VF minus VI, or delta V. I would need to use probably the momentum impulse theorem. It's asking me to solve for the change in speed. Now I could have used I equals M. I could have used this equation, M times delta V, because I've already solved for I in the previous problem. Or I could go back and do force times time equals M times delta V. Either way would have been fine. And I want to plug in my numbers. That would be 20.0 times 10.0 equals my mass, which is 3.50, times delta V. If it would have asked me to solve for my final velocity, I would have, written out VF minus VI and solved for VF. But it's not asking me for that. It's asking for the change in. So delta V, would be equal to, I want to divide both sides by 3.50. It's going to equal 20.0 times 10.0 divided by 3.50. So that would have been 200 divided by 3.5. It gives me 57.14 if I round 2 decimal places. And my velocity, change in velocity would have been in meters per second. Okay, next it says, Luigi is sick of taking orders. He swings a 9.0 kilogram hammer at 16 meters per second When Mario's mustache brings to a stop in 0.25 seconds, what is the net force exerted on Mario's mustache? Well, it's telling me the problem. If I write down my givens, my mass is 9.0. And its moving swings at 16 meters per second. That's going to be my initial velocity. And Mario's mustache brings it to a stop in 0.25 seconds. If it comes to a stop, my final velocity is going to equal 0. Then it's coming to a stop in 0.25 seconds. And then it's asking me to solve for my force. So my equation I'm going to use is this one. F times time is equal to m Vf minus Vi. My initial velocity in this case is 16. My final velocity is 0 though. So when I plug this in, it's going to be F times my time, which is 0.25. It's equal to my mass, which is 9.0. And I'm going to multiply that. If Vf is 0, that's minus Vi, and Vi is 16. That's going to give me negative 16. And then if I solve for F, I'm going to divide both sides by 0.25, so that would equal 9.0 times negative 16 divided by 0.25. So that give me 576, but see, it's going to be negative since that's negative 16. So that would be negative 576. And since I'm solving for force, that's going to be newtons. Now, I could say leave that as positive or negative. Either way, I showed that. The reason it's negative is because it's coming to a stop, but I could have showed my answer as positive. It really wouldn't have mattered in that case. A soccer player kicks a .450 kilogram ball at 25 meters per second east. If the goalie stops the ball by exerting 250 newtons of force, how long does it take the ball to stop? Alright, so I write down my givens. It tells me first my mass in the problem is 0.450 kilograms. And it's initially traveling 25.0 meters per second. And then so if the goalie stops the ball, if he stops it, that means the final velocity is going to equal 0 by exerting 250 newtons of force. So it's 250 newtons. How long does it take? I'm looking for the time interval. My equation, only one I can use is this one, F times T is equal to M Vf minus Vi. Plug in my numbers, that would be 215 times time is equal to 0.450. And this will be final velocity 0 minus initial 25.0. Now to solve for time, I'm going to have to divide both sides by 215. So my time is going to end up being 0.450 times 0 minus 25.0 over 215. So 0 minus 25 will be negative 25. So it'll be 25 times .450. That gives me 11.2 or negative 11.2. Then I'm going to divide that by 215. And that gives me 0.052. I want to go out to the first two non-zero numbers. So that would give me 0.052. And my unit, since it's time, is going to be in seconds. Okay, our last example problem. A 0.2 kilogram hockey puck is moving to the right at 4 meters per second. What's the velocity of the puck after a 30 Newton force is applied to it for 0.3 seconds? So it's telling me in this case that my mass is 0.2 kilograms. It's moving to the right at 4 meters per second. So that's its initial velocity. And it tells me what's the velocity of the puck. It's asking me for the final velocity after a 30 Newton force, so my force would be 30 newtons. It's applied to it for a time of 0.03 seconds. So again, I'm going to use the equation F times T is equal to M, and I need it in this form, BF minus BI. I'll plug in my numbers, be 30 times 0.03 is equal to 0.2, and in this case my VF is my unknown minus VI, which is 4. So what I want to do is kind of work this out. I want to extend it out where I have, this would be 30 times 0.03. And I need to distribute this out. 0.2 times VF would be 0.2 VF times VF minus 0.2 times 4 gives me 0.8. .8. And if I clean this up a little bit, on the left side that would be 30 times 0.3, which would be 9. 9 equals 0.2 BF minus 0.8. I want to add 0.8 to both sides. So that would be, I add it here, make it equal 0. I add it over here, and that becomes 9.8 equals 0.2 BF. Then I want to divide both sides by 0.2, 0. My final velocity would be would equal 49 meters per second. If I did the math right on that problem, that's what you should have got. Now, if we look at impulse and kind of review, impulse, in this case it says it's J, we used to I, those equal to force times time. The units are Newton seconds. It's also equal to change in momentum. Our change in momentum is m times delta v. So J equals delta p, which that means should be I equals delta p, the change in momentum. Other versions, I equals m times delta v, or F times t equals m delta v, or F times time equals m vf minus vi. All those variations of the equations we can use depends on what the problem gives us. Also, a Newton second is the same as a kilogram times meters per second. And you know, cushioning, if something collides with a wall, the less time interval, the more force it hits. If you can cushion it somehow, the less force it's going to hit. Same concept as an airbag. Same way with a pillow. You saw with the egg drop lab, the more you could slow it down, or the more cushion it landed with, the less force that was on the egg. Now what you should work on is this worksheet right here. And remember in the problems, like number 1, if it tells you something is at rest, it's telling you initial velocity is 0. If something comes to a stop, final velocity is 0. If it asks you for the change in momentum, again, you know, change in momentum from yesterday's lesson is m vf minus vi. That's what the change in momentum is equal to. Also, the change in momentum is the same thing as impulse also. That's why impulse can be equal to the change in momentum. So several of these problems ask you for the change in momentum where you're going to be using this equation from yesterday. Also, the answers at the bottom are to the correct number of significant figures, so you might not get exactly these answers. Number 1, you might get 241, and they rounded to the correct number of significant figures. As long as you get something close to these answers, you're fine. You're not going to get exactly on them. And really, we're being more accurate by going out 2 decimal places than rounding to significant figures. I'm not making you round to significant figures. We learned how to do that earlier, but I don't hold you to that all the time. I'm more concerned with you just learning how to work the problems. So as long as you get something close to these answers, you're fine. That is, if all the answers are correct. I think they are.